Hello everybody, thanks for joining me to this conference. For the next 30 minutes, we will talk together about the past, the present and the future of the HTTP cache. Let's see together how to accelerate your APIs or your websites using only the HTTP headers. So first, let me introduce myself. My name is Sylvain Combraque. I'm a freelance Golang architect and the creator of the HTTP cache tool called Swan. I'm also a French baguette, so sorry for my baguette accent. And I'm the maintainer of the Caddy cache handler module and an active open source contributor. By the way, you can find me on GitHub searching Darkweek and on Twitter searching darkweek_dev. So we have to go back in time near the end of 1998. HTTP 1.0 was released for 2 years, but the chaos between each providers like Google or Akamai because of HTTP 1.0 wasn't as extensible as they wanted. So they implemented some other features on their own way, and it was really painful to support each provider, all providers, with all of their features and all of their specific features. So HTTP 1.0 didn't explain in depth what is a request, a response, an HTTP header, or a comment in your HTTP request, for example, and it didn't explain the way to handle and manage the incoming data or what is prohibited and let the providers be free of the implementation. In June 1999, Matrix, the first movie, was released to theaters. We discovered Neo and the red and blue pills. Meanwhile, webfathers started to write and release an RFC to standardize HTTP 1.1. RFC is for request for comment, and it's like a big baguette blog that defines how a protocol must work. And its code is RFC 2616, or also known as HTTP 1.1. As it's the very first RFC to really standardize things, it will define the grammar. So what's an HTTP header, what's a resource identifier, and an URI that tells one URL must match to one thing on your server. It will also define what is an HTTP request, how to build it, which part can receive comments, which part must be did by the server. And it defines most of the HTTP headers always used nowadays. More specifically, in this RFC, there is an interesting part about the caching in HTTP, and it's the first try to standardize that. And it starts with the following sentence: caching would be useless if it didn't significantly improve performances. That means if your cache server responds slower than your upstream, you don't need this cache server. But nowadays, there are some other points. If your cache server is more energy consuming than the upstream, or is more cost expensive than the upstream, you may not need a cache server too. We can't only take in consideration the power and the speed to serve the data. As it's the first standard, there are some missing points, like the following. If a stored response is not fresh enough, the cache may still return the response with the appropriated warning header. First, who knew the warning HTTP header existence? To be honest, I discovered that by reading this RFC, and I'm pretty sure most of recent applications doesn't use that header, but that's a backorder from the past. And the most weird part is that the cache can return a not fresh enough response. So you are free to return a cached response to your client, even if it's considered as stale. The RFC 2616 introduced the cache control HTTP header and its own directives. There are the common directives that can be used in the request and the response context. The well-known no cache directive won't use a cached response in the request context and won't store the specified response headers in the response context. The no store directive won't store the upstream response. The message will tell to the cache server to store that for at most X seconds in the response context, and in the request context it should return the cached response only if it's stored for less than X seconds. The no transform directive will tell to the cache to not try to transform the request or the response, depending the context. It should not remove or add extra headers and not try to gzip the response to reduce its size. The request or the response must stay unchanged. The HTTP request cache control directive contains the max stale to explain, okay, you can serve a stale response, that means not fresh enough, and if that's stale since X second, less than X second. The min fresh directive is not really used in production because it's here to be able to tell to the cache, okay, serve the stored response only if it's stored since at least X seconds. So you cannot have a stored response that is fresher than X second. I don't have the use case for that. I don't know. And the only if cached directive serves the cached response only if it's present in the storage. So if your storage has a stored response, it will serve it even if it's stale or anything else. The HTTP response cache control directive contains the public that ensure the response can be stored by the shared cache, and opposed to that, the private that can be stored only by the private caches, like the browser. The must and proxy revalidates will revalidate the response with the upstream, and if no errors appears, it will return the stored response to the client. And the smessage will manage the stored duration on shared cache. There is a last directive named cache extension. This directive allows the user to add more custom directives only understood by the cache system itself. The first example adds the extension community with the value UCI. The cache system could increase the time to live for the response storage if the value is UCI, for example, and that's the same for the only if my case match with the given value that should. So during the summer 2001, a major improvement has been made. That's not the loft winners, but that's the ESI language. To be honest, this is not a validated RFC, but it's currently accepted by the W3C and integrated in most of your CDN or cache servers. The ESI language allows the templates, cache the templates, and only request the dynamic parts. In this example, we request the article.html content, and this page have a static article and a dynamic header called user.php. The ESI processor here, Varnish, will get from its cache the article.html file, parse it, and will see there is an ESI tag and will process it. It will send a request to the user.php endpoint on the upstream server, grab the response, and replace in the article.html body the ESI tag by the user.php received value. If you already wrote some HTML, you'll find that easy to use. And as the tag is not understood by the browser, it won't be shown to the end user or display an additional div if it cannot be processed. So it's really transparent to the user, unless it tries to read the source code of the received HTML file. Here, the ESI include tag will request the source attribute, here example.com/1.html. If it throws an error while doing the request, it will request the alternate back.example.com/2.html. And if we set the onError property with the value continue, it will just ignore the errors. A more complex one, we can do some try catches. The ESI try will try, as its name, the attempt subblock. If an error occurs in this block, it will just process the ESI except tag. You can see at the lines 3 and 7 some ESI comments that should be removed by the ESI processor, even you return them to the browser. Even if you return them to the browser, it will only increase the body size, but your browser won't interpret them, won't display them, etc. You can also load some variables from the request, and more precisely from the request cookies or request host, request path, and some predefined variables. And using the ESI vars, we will generate the image HTML tag. The computed source will take the value from the cookie name type. Imagine we set human as a value in the type cookie. Your source and your alt will contain, and your end user will see only the computed image HTML tag. So that's the demo time. So that is demo time to show you a more complex example and to prove that's very powerful. So I will use KDE as a proxy. So here is the KDE file here. My proxy will be running on the HTTP port. I said, okay, that's 80 and the common HTTP port. And I have some routes that return ESI tags here. I have a server route to proxy to a server the request that will serve also its own HTML or HTTP response, and all unmatched pattern here. We'll try to load the fixtures and we'll compute the response because of the ESI directive in the root block here. That's the KDE file syntax, but it's really easy to understand, and it's easier than the Nginx config or Apache configuration. Okay, in the fixtures, I have the complex example here named full.html that contains all ESI tags. We have some variables interpretations, some includes, some escaped content, and many other cases. So if I run the KDE server, here make run KDE, okay, it will take some seconds to build that, I think, and it run it here. So my KDE is running, and here make run server. Okay, so it will go in the middleware and just run main.go for make run server, and in Caddy it will run make run here, make build and make run. So it will build the ESI module for Caddy from the sources. So I have my two servers here, and if I try to request it, I can now send an HTTP request to the /server path, for example. So HTTP domain.com. That's a local domain. I edited my hosts on my laptop for that. And if I send on a /server, yes, I didn't set. I would like you to use curl for that. So it returns the headers because in the main.go I'm flushing the response each time I'm writing something, and I wait 9 seconds in total. And it will take that this HTML code and will parse the ESI include here. Here it's an escaped content from ESI, and I'm removing this include, and I'm using HTTP host here. So we have that in the response. And the more complex example, because here it's a bit simple, I can say, okay, try to load full.html, and okay, why? Okay, it's that's the demo effect, I think. We will debug that together. Why? That's this port here, and if I retry, it works. Okay. Okay, so it works, and I have my tags and other things. Okay, I think I show you everything. So I hope you enjoyed the demo. So we will jump some years later. And go at the summer 2014. That's the year the new Zelda Hyrule Warriors was released also. But some people prefer to write and publish RFC during their holidays instead of chilling, and the RFC 7244 34 2014 sorry, as known as the HTTP 1.1 caching, will add more context and more details and more use cases to the previous caching RFCs, and will invalidate them. First of all, we got a new HTTP response header called age. The age header explicits the number of seconds the response is stored. The second example should not occur. It should take the max between your age, your header age, and 0. So it details the cache invalidation. Imagine you store your GET response because it has to contact the database, and that's IO consuming, etc. If you build an REST API, you'll have the same path, but only the verb differ to manage your resource. If you send a GET request on /books/1, for example, you will store your response. And after that, if you send one of put, post, or delete HTTP request on your resource, you'll have to invalidate your stored GET response for this resource ID because these HTTP verbs will alterate your stored resource. This RFC had a new HTTP request cache control directive named stale while revalidate. This one allows the cache server to serve a stale response and try to revalidate in the background with the upstream and store the freshly response and replace the stale one. That ensure client will receive data even if your upstream is done. Add this header to every request when you think it's okay, even if your clients have some stale data. In June 2022, I was in Greece, but Mark Nottingham decided to release two RFCs to the cache status RFC and the targeted cache control HTTP header. About the cache status header, it defines some useful directives. The first one is it, and I missed that. You can now detect if it was hit by your cache server or missed. Forward, add more context about the cache server that forwards the request to the upstream. Forward status returns the status from the upstream or another cache server. The TTL shows how many seconds the cached response will be considered as fresh. By the way, the age header plus the TTL should be equal to your storage duration and must be equal to that. The collapsed directive tells you if the response has been built from one part of the cached response and the second part from the upstream. For example, the key give you the stored key in your cache index, and the detail give you some details from, for example, if it's not stored because the response storage is unreachable. So the cache status header is like that. You have your server cache name, if it's it or not. If it's it, you have a TTL. You can have the key, etc. And in the last one example, you have the case that the storage is unreachable. Now, the targeted cache control RFC allow you to manage automatically the cache control. Imagine this infrastructure. Your client would send a request to your server. His request goes through the CDN, and it will proxy to your Varnish cache server. It will send the request to your KDE instance that will transfer to the upstream. So the upstream returns a response with 4 headers: the well-known cache control, the CDN cache control, the Varnish cache control, and the KDE cache control. With their own duration, their own storage directive. Imagine you can have, for the CDN cache control, a private directive. And the KDE instance will check if the KDE cache control header is present and will store the response for 1 hour. Then Varnish will store for 5 minutes, and the CDN will store the response for 2 minutes. And the client will store that but won't use it because of the no cache directive. And if the wildcard cache control header is present and interpreted by your cache. For example, imagine varnish doesn't recognize the varnish cache control. It should and it must fall back on the basic cache control header. And here our client will store it but won't use it because of the no cache. Okay, thank you for your attention. Thank you to the organizers team. Don't hesitate to ask your question if you have any, and I hope you found that interesting.